So now we will see a next question which is based on the application of Lamis theorem. In this question they have mentioned that three cables, okay, there are three cables which are joined at the junction C. So this is the junction C and you can see there are three cables, 1, 2 and 3. I'll mention it over here with the different color. So let it be, this is 1, this is 2 and this is 3. So there are three cables and joined at the junction C as shown in figure. Determine the tension in cable AC, so this one, okay, and BC caused by the weight of the 30 kg cylinder. So here the weight is given to you and this is of 30 kg. Then they ask for the tension in the cable AC and AB and caused by the weight of the 30 kg of cylinder. So in order to solve the problem, the first step is to draw free body diagram. Okay, in order to understand ABDs in a clearly, I'll first erase this and now I'll enlarge this figure so that you can easily understand the free body diagram of this question. Okay, so as it is mentioned in the question, there are three cables which are joined at the junction C. So we'll take a FBD about point C. Now if I consider point C, then all three cables are under tension. Cables are always carrying what? Tension, that is a tensile force, and tensile force is always away from the considered point. So if I consider point C and if I want to show a tension AC, then it is away from the C point. Means the direction is like this, it is away from the C point. If I want to show the tensile force in the cable BC, then it is away from the C point. And now this cable is attached to the weight kg. Of course this cable is under a tensile force and we have to show the tensile force in Newton. So Newton is calculated by multiplying 9.81 to the weight. So this value becomes 30 into 9.81. Now see here, it is a frictionless support or a spherical object, or you can say a pulley, okay. So there is no friction, that's why whatever the value over here, that is 30 kg, is taken over here by multiplying 9.81 in order to show the tensile force into Newton. Now this is tension AC and this is tension AB. Now I'll draw the same FBD over here. So first force is 30 into 9.81. So the value comes out to be so it is 294.3. And this force is making an angle of 15 degree with the horizontal. It is making 15 degree with the horizontal. Now I'll go for the next force, that is TAC, but if I draw a horizontal line over here, then this angle is this angle is 90 degree. So of course 90, 45, so this becomes 45 degree. Similarly, if I consider this triangle, so this makes 30 degrees. Of course this is a 90 degree, so 30, 90, so it must be a 60 degree. So same thing, I'll show it over here. So now I'll draw second force. And this is TAB. and this makes 60 degrees with the horizontal. And last force is TAC, which is making 45 degrees. This is TAC. So this is the FBD considering the given question. Where TAC is making 45 degree with the horizontal, then TAB is making 60 degree with the horizontal and 15 degree of weight with the horizontal. So now I'll consider these three forces for the further calculation, and I'll apply Lamis theorem in order to find out tension in the AC and tension in the AB. Now according to Lamis theorem, we have already discussed what is Lamis theorem and how to apply it. So according to Lamis theorem, if I apply the equation, then equation will be, I will go with the known value, that is 294. So 294 divided 0.3 divided by the angle between other two forces, the angle between other two forces. So this is 45 plus 60 becomes, I consider the whole angle between these two. So this angle becomes 105, 60 plus 45, this is 105 degrees. So I'll mention here sine of angle between other two forces, that is 105, which is equal to the next force, that is TAB, tension in the AB, divided by sine of angle between other two forces. If I consider TAB, then other two forces are these two, TAC and 294.3. So now I want this angle. So this total is 180, 180 minus 45 minus 15. So 45 plus 15 becomes 60, and 180 minus 60 becomes 120 degrees. I repeat, the whole angle with the horizontal is 180 degree. Out of that, if I subtract 45 and 15, I'll get 120 over here. So the angle between other two forces, if I consider TAB, then it is 120. So sine of 120, which is equal to the last force, that is TAC, divided by sine of angle between other two forces. Now if I consider TAC, I want this angle. Now I know this is 60, so this becomes 30. This is 90, as you can see in the figure. So total angle is 30 plus 90, 120, 120 plus 15 is 135. Okay, I repeat, 30 plus 90 plus 15. 30 plus 90 is 120, 120 plus 15, 135. So I'll mention here 135, sine of angle between other two forces, that is sine 135. So I'll get this equation. Applying Lamis theorem. After applying the Lamis theorem, I'll get this equation. Now I'll solve the equation by equating one by one. Let it be, first I'll consider these two equations, this one and this one, and if I equate this two, I'll get the equation TAB, which is equal to TAB, so 294.3 divided by sine of 105 into cross multiplication, that is sine 120. So if I solve this, (294.3) into sine 120 divided by sine 105. So this answer is coming around 263.862. 263.862 Newton tensile force. So it is Newton. So TAB here we are getting 262.862. Okay, so this is my first answer. Now I'll proceed further and I'll equate the TAC with the 294.3 by sine 105. Now I'll equate this, now I'll equate this value with TAC, this ratio, these two ratios. So my equation will be TAC will be equal to this ratio 294.3 divided by sine of 105 into this cross multiplication, so sine 135. So if you solve this, 294.3 into sine 135 divided by sine of 105. This is 215.44 Newton. So this is the value of TAC I am getting after the calculation and after the application of Lamis theorem. Okay. So I repeat the whole solution once again with you. See here what we have done. So there are three cables as per given in the question which are connected at junction C. Here. So now we completed FBD at point C. You can see here. So there are three tensile forces passing through point C: TAC, TAB and TCD. TCD is equal to the weight of the cylinder, weight into 9.81, because tensile force which is carried by the cable must be in the Newton. So that's why we have converted this into 30 into 9.81. So the value is 294.3. After getting concurrent force system with the three forces, we have already studied how to apply the Lamis theorem in the previous session. So here I apply Lamis theorem, where we have considered TAB divided by sine of angle between other two forces. Similarly then TAB and angle between other two forces, and then we have solved this by equating the ratios, and we got the value of TAB and TAC. So this is the complete solution for the given question. So this question was asked in the SPPU for the 5 marks, and here we have seen the application of Lamis theorem. Now we will proceed for the next question.